Hi there, welcome at this use case of a unified namespace in practice. Today we're sitting together with Koenraad from BMT Aerospace. So welcome at this case study. So before I would like to start with the presentation and talk about BMT Aerospace, I would like to start a little bit about AT Automation. So I'm from AT Automation. We are located in Weert and we have 3 departments there. So AT Automation is an industrial automation company who has the 3 departments: controls engineering, ignition, and robotics. With the controls engineering department, we have 2 solutions that we provide. So that's our service and maintenance engineers that help our customers. So they can upgrade machines, they can do the maintenance work for the companies that we work for, but they will also relocate production lines. And we particularly do that within Europe. We have moved many lines the past years. We also have the controls engineering department, which is working on PLC programming, HMI programming, E-plan drawings, and all such sort of work. And of course, the result is always a control cabinets that we make for our companies. For those customers, we specifically rebuild machines, so older machines that need revision. We can do that with the controls engineering department. We also have a robotics department where we make turnkey robot solutions, so we can help our customers with that. Then we go to the SCADA MES IoT department, where we work with ignition, and we also provide, of course, the training. Well, if I explain these departments to our customers, I mostly show the automation pyramid that we can see on screen here. And with AT Automation, we cover the entire pyramid. The lowest 2 lines, the sensors, actuators, PLC, HMI, we cover with the controls engineering department and the robotics department. And the upper side, HMI, SCADA, MES, and IoT, we cover with the ignition or SCADA MES department. The ERP, we don't really cover, but we connect to that. So we do have a lot of integrations with that. And on the left side, we do see IoT, Industrial Internet of Things, that we also cover with AT Automation when we need to collect data at edge locations. Then today we are in conversation with Koenraad, as I already mentioned. First, let me introduce myself. My name is Bart Mans. I'm an innovation manager at AT Automation. I work here for 10 years now. I was one of the first who worked with ignition at AT Automation and also in Europe. And we worked with ignition for 10 years now. Did really cool projects. And one of those cool projects is with BMT Aerospace. Please, Koenraad, introduce yourself and let's take a look at this use case.
Yes, hello, I'm Koenraad Lievens. I started working for BMT Aerospace 3 years ago. And my job is to set out the Industry 4.0 strategy for the whole company. And in that process, we chose to use ignition for our MES and IoT platform, and there we partnered up with AT Automation. But let me first explain what BMT is all about. So BMT is part of the BMT group. The BMT Aerospace, is part of the BMT group. So and the group consists of 4 divisions. So we have OMCO, they make glass molds and castings. We have IGW, they make gears for industrial applications. And VCST, they make gears for cars. BMT Aerospace makes mainly gears and gearboxes and actuators for aircrafts. And we do that in different steps. So we buy raw steel from a smith, and then we'll apply different applications. So gear cutting, milling, grinding, deburring, broaching, copper plating, carburizing, quenching, shot peening, and phosphating. And so all the gears and all the parts that we make usually go through all of those processes. We do that all in-house, and we're completely vertical integrated. The most common parts that we make can be seen here on these pictures. So, and for aircrafts, we have parts in the wings, in the engines, and in the rear of the aircraft. So here you can see in the rear we have the auxiliary power unit. That one provides electricity and oil pressure and airco when the airplane is on the ground, when the engines are not running. Then we have in the wing, we have the actuators of the slats and the flaps. The slats are in the front, flaps are in the back of the wing, and they provide extra lift, which is needed when you land or when you take off. And then in the engines, we have also the gears and the complete auxiliary gearbox that allows you to maintain all oil pressure, electricity, airco, and so on when in flight. We also make parts for helicopters, and these are mainly the bevel gears on the main shaft and on the rear shaft. So here you can see the rear shaft. There are two bevel gears to change the direction of the rotation, and here as well to go from the main shaft to the main rotor and to the after rotor.
Yeah, and with that, thank you, Konrad, for introducing BMT. Of course, we came in contact. You had a challenge. You wanted to uniform the connectivity between OT and IT because there was, of course, a need. Can you explain a little bit on the challenge that you had and why you partnered up with us and saw Ignition as one of the solutions?
Yes. So when I started at BMT, I made a map of what they already have to see where was my starting point and where did I want to go to. So on the IT side, they have BMT has an ERP system, a PLM system, a cloud, reportings, and different applications. And on the left side, we have the existing shop floor with PLCs, HMIs, some sensors, and of course a lot of paper and Excel sheets and so on, and a very basic MES system.
Yeah. And so whenever we take a look at one of our customers, we see many different variants of these. I think in your setup, and you will show that in a bit, is that there were correct connections between OT and IT, but it could also, of course, be the case that there is no single connection and OT and IT are completely divided.
Yes, indeed. And that would be sometimes that would be an advantage. Then you start with a clean sheet. But in my case, there were already a lot of connections. Well, for example, from the shop floor, there were connections to the ERP system. There was some kind of a HTML page that made SQL queries and showed the planning from the ERP system to the operator and so on.
Yeah.
And then the operator could start and stop the machines with the HMI. And there were connections to the PLM system so the operator could see the documents that are embedded, that are saved in the PLM system. And there was also a cloud system where we would show some sensor values in a graph and so on. And the more I kept looking, the more connections I found. So I also found out they're still using a lot of Excels because the ERP system was very old and didn't allow you to do detailed planning. So they did the detailed planning in an Excel sheet. Also, measurements were made in process. Measurements are done on paper or in an Excel sheet because the PLM system was not is too old to accompany that, and so on. So there's a lot of extra connections. Then we had sensors to measure the energy consumption of our machines, and that was done via a special app that was in the cloud, and then you could monthly download that from that app and put it in an Excel sheet, and then you would have to copy paste that into some other Excel sheet for reporting and so on. It was all a lot of work. A lot of manual labor was still needed, the manual interventions each time, because so the red arrows that I use, these mean that a manual action has to be done, while the blue arrows are already automated. So, for example, some of the sensors were connected to a gateway, and that would encrypt the data, put it in the cloud, and then you could download it back from that cloud and put it in your own database. It was all very cumbersome, all with a lot of operational costs, cloud subscriptions, and so on. Well, if it works, you could say, well, leave it be. But in the end, there were so many of these connections that it was very hard to manage it, very hard to even to already map it was already a lot of work, but then also to manage it, to keep it up to date, because what happens if one of those systems if one of those systems has to be updated, or if you want to add something like machine learning, then you would have to gather all the data from all the different components, and then you would have to you would make some kind of a feedback system towards the PLC. So that means that all of a sudden that the PLC is being driven by data from this spaghetti network, and that means that your whole network has become production critical. While before, if you make measurements in an Excel sheet or you make a planning in an Excel sheet, you can still talk to the operator, and even if the Excel sheet crashes or is forgot to save or something, you can still talk with the operator, and production is not interrupted. But once you start automating things and you start sending automated commands to your PLCs based on measurements made with one of those components, then everything becomes production critical. And so BMT never made that last step here to automate, because they were afraid of their spaghetti network. It was not robust enough. It was not secure enough. So they were unable to make that last step. So I saw that as my first task, to get rid of this network and replace it with something more robust and more manageable. Because another example, what happens if one of those items, one of those applications gets an update, a software update, and the communication protocol changes. For example, we have the sensors, they're connected to the cloud, and the cloud provider decides to make an update, and then all of a sudden we have to start programming in 2-3 different places, all the places where these sensors are being used. We have to quickly adapt them. If we don't adapt them, you get this kind of a waterfall reaction where more and more applications stop working. They grind to a halt because they cannot get the sensor data, they get an error, so it means our reporting doesn't work, in the database it's not correctly logged anymore, the application, the machine learning application, for example, doesn't work, and that one was connecting back to our PLCs, so the PLC stopped, so our production grinds to a halt, all because somebody made an update to a sensor. So that's one of the pitfalls of such a network. It's really hard to manage and to keep it up to date. So upgrades basically what you do is you don't upgrade it anymore. You say it works now, let's leave it as is, because with every upgrade we always have troubles, we always get production delays and so on. So you stop upgrading. So it means that your security becomes a mess. It's more secure because of confusion than because of actually security. Because actually nobody really knows which connection goes to where. And then adding and removing a part is also almost impossible. Replacing the ERP system that has 10 connections to 10 different applications is really hard. That means that all these other 10 applications will have to have their code adapted. So you'll have to start programming at many places simultaneously. And so I came up, the goal was to have a more unified network, cleaned up network, where there's always only one connection. The ERP system talks with an API with a data hub. The PLM system as well. The sensors send their data, for example, via the broker, via MQTT. The MES system also directly talks with the data hub in the middle. So we went for a hub spoke model, and that has a big advantage. If now we want to upgrade our ERP system, the only link we have to make sure that continues to work is the link from ERP to the hub spoke. And if the data is still available in the databases of the data hub, then all the other applications will continue to work. So the main goal was, we wanted to update our ERP system. That was one of the triggers of this whole project. And so, and then we saw that our dashboards for the operators wouldn't work anymore. So we needed a new MES system as well. And we wanted to have a better integration with the PLM system. So that was the main goal. We wanted to have a new ERP system, so I had to make sure that the operators would still see the planning. And then as a secondary goal, we also wanted to get a better visibility on the shop floor and an ability to add more dashboards and more applications later on. And then we also wanted to have add an IoT part to it, so where we would add additional sensors, measure the power of all the machines, get an overview of all the machine states, whether they're in run, whether they're in stop, whether they're in unexpected stop, and so on. And there I wanted to set up a skeleton for where we could attach additional sensors later on. Because now the question is, can you measure power, water, and gas usage? But and tomorrow it will be, can you also measure the temperature of the cooling fluid or the pressure of the pump, and so on. So I wanted to set up a skeleton where later on we would easily be able to add additional sensors with an almost plug and play ease of use. So and that's how I came up with this solution. So we have our hub is the part in the middle, the IoT server on premise. So we also wanted to have almost everything run on premise, to not to be dependent on internet connection, and also to have to make sure that our data is stored locally. So there we went with Ignition and a broker. So all the data passes through the broker. We started using the Unified Namespace there as a structure within that broker, and Ignition plugs into that broker, and it syncs its variables with that Unified Namespace. As we have everything passing through the broker, we can easily have a Canary, a time historian database, tag every change in the UNS with a timestamp. And that way we have time series available for all our parameters within that UNS. There we went with Canary time series database from Canary Labs. And then, of course, we have an SQL database connected to the Ignition gateway. Via APIs, we go to the top we have connection with the PLM and the new ERP system. And of course, we can also show their dashboards where we show OEE or other key parameters for management. And then if we go to the bottom of this slide, then we'll see that there are 3 blocks, and I see these as the 3 inputs for my system. So we want to gather information from our shop floor. I want to know what is happening at the shop floor. I want to and I want to be able to show that to the management. So there's 3 ways to gather information. We can ask it to the operator, and that we do with the MES. We show him the planning for today, and we ask him what is his progress in that planning. And we can also show him the documents that he needs, the process descriptions and so on. We can show him, we can download that from the PLM system and show it to the operator. A second way to gather information from the shop floor is by talking with the machines. We have around 380 machines with PLCs inside them, and they talk with different protocols. And there also one of the big advantages of Ignition was that Ignition is very open in its communication. So we could easily add extra protocols, or a lot of the protocols that we wanted were already in Ignition out of the box. And so currently in Belgium, we already have, I think, 99% of our shop floor connected with the Ignition and is logging data in the UNS. And that's after 1 year going operational, 1 year after the start. And just to let you know, we have 380 machines. We have 70 different brands of machines. So they also have a lot of, so it's a real brownfield factory with a lot of different brands, a lot of different protocols that these PLCs stock, and we were able to connect all of them with Ignition. That's one of the main advantages for me to start using Ignition.
Yeah, I think that's a really important thing that you mentioned there, Konrad. So you indeed have a brownfield, which has many different PLC brands, many different machine brands. They can, of course, have same PLC brands, but yeah. So you really have a brownfield which you inherited, and there is a lot not standardized, or there are different versions.
Yeah.
You just showed with all the systems and the integrations between the systems that on that perspective, it's also the same. So many customized, many different brands and different systems that will or will not communicate with one another. There's maybe some manual work. So you're really outlining, I think, the challenge that you had. But that was one challenge. But the other challenge was implementing a new ERP system. And I think that triggered actually this discussion and this project that we have been working on for the past year. And I think that's cool that there, a great job has been done. Also, a little shout out to Yuri, one of our engineers. But I think that summarizes the challenge you had, and also the goal that you had, and the steps that you have taken.
Yeah.
I think the upcoming slides will go more in. So that was more the theoretical side. The upcoming slides will go more into the practical side and on the technical side, how the connections were made and such.
Yeah. And to continue on that same topic of the connectivity of Ignition, indeed, we're changing the ERP system. And we managed to have our new MES system that we built in Ignition. We managed to have it connected with the old and with the new ERP system, which means that we can seamlessly switch over from the old ERP system to the new one. So it also shows how flexible Ignition was. The old system worked with SQL queries. The new system, ERP system, works with API calls. Ignition can do both, and so now we already switched to the new MES system. We're still on the old ERP system, but the operators won't notice anymore when under the hood we change ERP system. For them, they now have a new MES, they have a new dashboard, and for them nothing will change anymore.
Yeah, so it's really a composable setup. So you can compose the old ERP system and choose the new one.
Yeah, indeed. Yeah. So it makes a less of a hard stop for the old ERP system and a hard stop for the new one. It's more a phase in and phase out, and makes it much more manageable and the changeover. So to go back to my story, so we had MES where we can talk with operators. We have the PLCs where we talk with the PLCs of the machines, and then we've also added extra sensors. Perhaps indeed we have that in the next slide. Indeed. So for the MES system, we can show them the planning. We can ask them to clock. We can control the shop floor more, and we can gather data for OEE equipment monitoring and so on. And that can all be fully integrated with the ERP system. So when the operator clicks on "I finished the part," that immediately goes via the Ignition gateway with the API to the ERP system. And then a second way to gather data is the existing PLCs. They have a lot of information. So they have an inner loop where they run at 20 milliseconds or so. And then with an outer loop, we try to gather data from them on a lower frequency. We ask them, what is your status? What are your alarms? What is the sensor values and so on. And then here with the, as not all PLCs have enough sensors, or there's a question from engineering to add an additional sensor and so on, we've added extra PLCs, soft PLCs, where we run partially PLC and partially Windows with Ignition Edge on it, and there we can attach as many sensors as we want. So that's the skeleton I was talking about. We have in total 17 of these extra cabinets with soft PLCs in them, where we can 17 of these cabinets spread out over the shop floor, where we can easily attach extra sensors and read the machine power, read the vibration of the pump or of the spindle, the temperature, and so on. So we started out with some basic measurements, power, vibration, and temperature, but it's, like I said, a skeleton where we can later on add additional sensors.
Yeah, so actually, no matter what data you want to add to your system, if it's operator input, it will be coming from the MES system, which is Ignition.
Yeah.
If it's a machine input that already is available, like a sensor, it's coming directly from the PLC. And if it's another input, another sensor that's not yet available, you can add it to that IPC, soft PC, PLC, what you just mentioned, running Windows, Ignition Edge, and then also being sent to Ignition. And all of that goes through the MQTT broker, of course.
Yeah, so that means that all of that is logged in the Canary time historian. Yeah. And to get all of that nicely structured, we used the Unified Namespace. So there we, all the data is being stored in this structure, in this database structure. So there we started with the same structure as our ERP system. So there we have an enterprise site, area, production line, work cell, and so on. And what we've done is we've added here, in that structure, we've added some extra folders for extra information for dashboards and so on. And this is and this allows us to make these dashboards and to go and to really drill down very easily. So we can, here you see an overview of all the departments, and then if you click on one of the departments, you go one folder down and you see all the work centers. If you click on a work center, you go again one folder down, and then you see a detailed view of what the machine is currently doing, and what are the values of the sensors attached to the machine. Yeah? And then so we are able to make these kind of dashboards in Ignition for continuous use, for more fixed use by operators or by shift leaders or managers. But it's also Canary Labs also has a Axiom user interface where you can make new graphs on the fly. And these are really useful for your process engineers that can quickly click on a few of the parameters in the Unified Namespace, and immediately they can see a time graph of those parameters to find the root cause of a machine failure or a scrap part and so on.
Yeah, and what you also see with that Axiom Canary Labs connection that you made here, we are of course historizing the entire UNS, which actually means that we can go back 1 year in time and grab a snapshot of the entire factory and see what happened then. Yeah. Who was logged in? Who made this change? What was the value of the temperature outside? What was the humidity? Yeah. What was the speed of the spindle, and so on? All of that information is logged historical, so that you have the entire snapshot of a factory.
Yeah. And so, to facilitate all of that, we've created 4 types of folders in our UNS. So the first one is descriptive. So a work center has a description. It has a serial number, a date of taken in use, date of purchase, and so on. Some almost static data. Yeah? This can be used in dashboards to show And then we have functional folders, and these are more calculated, or they come from other places. For example, the ERP system will tell us what the planning is for that work center for this day. The state, we get it out of the PLC. The MES will tell us which operator is running on that machine, and so on. So these are function calls, and then they store their data in these folders. And then we have ad hoc information, and that's well, each PLC is different brands, but also different types of machines. A grinding machine will not give you the same information as an oven, for example. So the structure within the PLC folder is an ad hoc. It will always be different. It will be different for each work center. While the previous ones, the descriptive and the functional, we try to keep them as much the same for each work center as possible. And then we have informative folders, and there we gather all the information that we show in the dashboard. So it could be just links to the functional or the descriptive or the ad hoc folder. And the reason that we do that is that this way, whatever the operator sees is also being logged in the time historian. And like Bart just said, if you then take a snapshot from a year ago and you say something went wrong at that point, you can see what the operator saw, and then you can see on what the operator clicked. And so you know exactly why he clicked on that button or why he started that machine, because you know what he information he got out of the system, and then you also know what he did. And this will later on, and that's not only for operators, but it's for every application. So we have for dashboards, but also for the historian or for other applications, we make these folders where we set the data ready to be used by an application. And this will later on help us a lot once we move to machine learning, because then I want to know what was the input and what was the output. And then I can train a model that will predict the output based on the input.
So and I think what is important to mention here as well is we're now talking about 4 different types of folders, which is informative, functional, ad hoc, and descriptive. Mm-hmm. But the names themselves, we together with BMT Aerospace, we came up with the naming: dashboard, ERP, historian, MES, PLC, asset, and so on. Those names. Those were set up in consultation, so it isn't a fixed name. We're just defining here. I think that's what you're doing here, Konrad. You're defining the types of folders, the naming of the folders themselves. We have many different options for that. We at AT Automation, we also have a webinar called UNS in Practice, and there we also go over the different types of folders and how you can then name them, because a lot of companies are struggling in what would be a correct naming. But there are many different variants, and all of them have their pros and cons, of course.
Yeah. Well, my advice would just be go for find some kind of a structured naming and stick with it.
Yeah.
And then, of course, these 4 types of folders, they also make it a lot easier to then later on build upon it. It makes it more future-proof.
Yeah.
But of course, even with all this information, we thought, now we have it. Now we have our final UNS. But it's one of the learnings that we have from this project is that it's UNS. It's hard to define it in one shot completely correct. So we already had some evolution there. So, and one of the reasons that we made changes in this structure that I just explained is, what if a work center changes? If, for example, an oven could be in department grinding, and then later on we decide to put the oven in the department milling, for example. That means that all the data that was in our canary historian that will stop. All the folders will stop to exist in department 1 and will start to exist in department 2. So it means if you want to make a graph of that machine that spans over a time span that went over that change or of move from department, that you will have a gap. You will have graphs that stop at that time, and you will have other graphs that start at that time. And we wanted to avoid that. And basically, what we decided was most of the graphs that we make are based on the data from the assets itself. So a work center is, for example, a milling machine with a cooling machine next to it, with a robot next to it, with a tower next to it, and so on. So one work center consists of multiple assets. And sometimes we, in the shop floor, we want to keep the flexibility to be able to swap assets within work centers, or swap work centers within departments. And so here, if we move an asset, for example, you get almost the same problem there. If you would move a robot from one milling machine to another milling machine, all the data of that robot is interrupted. So if we want to make machine learning later on that robot, or we would just want to show a graph of the usage of that robot, it will always have to show two graphs, one before we swapped it and one after we changed it. So there we started looking at what are our options, what can we do to change our UNS. And that's the nice thing about UNS, it's completely free. Not only the naming, even these 4 types of folders, it's just that something that is very useful, but it's not mandatory. So what we did, we went over all different options, and we saw there's like 3 different options. You can do top-down approach. You can start where you say, I start with the plant, and then I go down to the department, and then I to the shop floor, to the departments, to the work centers, and so on. So kind of a drill down that follows usually the pyramid that Bart showed on his second slide.
ISA 95 structure as well.
And that also follows the structure of most ERP systems. So that was the most logical, that we would go that way. But there we bump into that problem that graphs have to be remade whenever you make a change in an asset or a work center. Another way is to do it bottom up, where we say we start with the assets, and then we have like a flat list of all the assets, and then we say this asset belongs in a certain work center and belongs in a certain plant, and so on. Has some advantages. Now, assets usually never change. They have a name, they have a start date of bringing an operation, they have a serial number, and so on, and they have a fixed name that never changes. The robot will always stay that same robot. And here we can swap all the different. We can put the robot from one work center to another work center, and there will be no interruption in the graphs or in the dashboards that we create based upon them. But it's harder to make that drill down. The dashboards that I showed earlier, where you say these are the different departments, and then you click on a department, then you go to the different work centers and so on, that drill down, that becomes much harder to build automatically. So the dashboards that I showed you, they were automatically generated based upon our UNS, and we wanted to keep them automatically generated, so that if we make a change in the UNS, we don't have to start coding in our dashboards anymore.
And the same applies for the engineers who are searching for parameters. They will probably go from site, area, line, or work center, and so on.
Yeah. So that's why we came up with a hybrid solution, where we tried to combine the best of both worlds. And that's basically, we keep our top-down structure where we can do the drill down, and in that so we have our work centers, our departments, and then work center 1, and then work center 1 consists of assets, and there we have a array of the different assets. So work center 1 consists of a CNC, a cooling, a robot, and a tower, and a measuring machine, for example. And that array of assets links to a flat list of all our assets. And so it's easy to find your asset, and then you can go to the correct asset, and there you'll find all the trending data. How many hours is it in use? What's the vibration, and so on. That data will be in the asset itself. And this is what we are currently implementing, and this is our latest state. Hopefully, it's future-proof, and yeah. But I have a good.
We'll see coming years.
Yes, indeed.
But indeed, so this is a nice example of how you can set up the UNS and how you can make a structure. As mentioned earlier, there are many different options, and this potentially could change later as well. I've seen a few variants now on the BMT UNS, of course, but also in other companies. And there are many different options, as I mentioned. We have also seen UNSs that inherit multiple languages, because then you change the language and then your entire structure changes. Of course, that becomes more difficult whenever you're looking at historizing data. Then you would need to have one standard UNS, for instance, that's the English UNS. And whenever you change to German or to French, your UNS structure gets restructured. However, whenever you look at a data point, you will always take a look at the English data points to find the structure. There are many options. As mentioned, the webinar UNS in Practice goes through them. But this is already a nice looking setup. And I hope, Koenraad, as well, that we're able to stay with this setup for the coming years.
Yes. Because changing your UNS, it's possible, but the further you get in your project, the more work that goes into it to make that change. So that's why it's important to set it right from the first time, but it's almost impossible to do that. So it's iterative process.
Yeah, and that's like also why you try to start small while setting up the UNS. Start with the first machine or first department, and then try and find out, and then you find out, hey, we're moving assets. We need to change this before you have rolled it out in many departments and many sites.
So that concludes my more practical and technical information. So just to show you what we did. So this is like a one slider about the strategy for the company, where when they hired me, they asked me, can you make sure that our factory can go lights out, which means no more need for operators, where we have everything is done by robots and machines and so on. It's a utopia, of course, but that was the goal. So I had to tell them, make it clear that this is a strategy you're following. It's not a project. It's not like you'll be able to calculate the return on investment for this, and we'll have to do this in many steps. In this case, I drawn out 6 steps. First, we have to start with computerization. So everything has to go digital. No more paper on the shop floor. No more paper in accounting and so on. Everything has to go digital. And we did that with the ERP and the PLM system. And then we have to have everything connected. All the machines have to be connected. We are after 1 year with Ignition, we managed to do that. And then also IoT. We want to have additional sensors, measurements done. And there we also used Ignition and then the Canary Time Historian and the extra soft PLCs, where we are able to measure make additional measurements on the machines. And actually today is the day that we go live with the IoT in BMT Belgium. It's a coincidence. And then the next step would be the visibility. So that's where we're working on now most, trying to visualize, to show what is the status of the shop floor. What are we measuring? And so we can show for management, we can show key parameter indicators like OEE and so on. But for operators, we can also show graphs of trending graphs of their measurements, of their adjustments that they have to make to the machine. And you can start doing some statistical processing control to set alarms and so on, and to visualize to the operators whether they have to take an action or not. And then we're also moving into transparency, and that's where so to be able to understand the process and to really know why something is going wrong, why are you creating scrap, why is the machine running slower than expected, you need to have a process engineer look at it. And in the beginning, we were constantly asking the process engineers, hey, can you help us with getting data out of that PLC? You know which parameters we should log and so on. And in the beginning, the process engineer's answer was really simple. I'm too busy. Don't bother me. I'm not interested. Yeah? But then so what we did was we started with some basic parameters that we managed to get out ourselves with the OT team. And we put that in the UNS. It goes into the Canary Historian. And with the Axiom dashboards of the Canary Historian, the engineers could immediately plot out all these parameters, see the complete, see a time window of these parameters, see a trend of those parameters. And that triggered those engineers to see the value of the UNS. And now it's the other way around. Now the engineers are constantly asking the OT team, hey, can you also measure this parameter? And can you start logging that parameter and so on? So it made sure that our OT team is only 3 people. That's including me. So we're way too small to start mapping all these parameters on all these machines. But all of a sudden, via the Axiom, we made it available to engineering. And now we have the complete engineering team that wants to help us because they want our help. So that was a real eye-opener. The combination of Ignition and Canary was really good.
Really bridging the gap between OT and IT, I think, on the engineering side. And indeed, you're at BMT Aerospace, we're using Canary Labs with the Axiom platform, which is actually a visualization of the historian of Canary Labs. Ignition has many different historizing options. So we also have done projects where we use the Ignition internal historian, and we use an SQL database, for instance, for it. But since we're using here many data points and we wanted to have a specialized program, store that data, real-time series, optimized database, the choice has been made to go to Canary Labs and the Axiom platform as well.
Yeah. And by the way, Ignition integrates out of the box with Canary. It's just somewhere you have to enable one option, and from then on, everything is locked. And it was really easy to do. And then we're already starting with predictive as well. There we started with a machine learning workshop where I made a selection of the brightest engineers, or the ones who had the bravest engineers, let's put it that way, and to start learning how to do machine learning. And there we also have already have a few projects where we are trying to make predictions based on the measurements from our sensors in the UNS. And as you can see in this graph, the value of these projects that stem from this whole strategy, the value is only further away in the future. It's only when you start doing transparency or predictive capacity that you really start getting a lot of value. Visibility is nice, but does it make your shop floor run faster? Not really. If you have good operation managers and shift leaders and so on, and they talk a lot with the operators, they probably already know most of the stuff that's happening on the shop floor. But once you start with transparency, you start to understand the system. System engineers, they start understanding what's going wrong on the shop floor. That's already a big value. And there we had and we were able to make some of our processes 25% faster. Increase the efficiency by 25% on one of our machines. So that was already a big value creator. And now with the predictive capacity, the value will really start increasing of this strategy.
Yeah, and as you mentioned, and is also in this drawing, the sequence is important. You cannot do that when you just have an ERP and a PLM system. You would need to have an MES system and everything connected.
Yes.
You would needs to be visualized. It needs to be transparent before you can go to those steps. And that's a really important step.
That's why I made this slide, to convince management that we really need an MES and IoT system these are the two primary steps that you have to take. You cannot. They said we have a lot of data in our ERP and in our PLM system. Isn't that enough to already start working with AI? I had to make it clear to them, no, there are still a lot of steps in between.
Yeah.
Yes, and this brings me to the end of this talk.
Yeah.
So,
thank you, Koenraad. I think it was you did a great job by explaining the steps that we have taken the past year, coming from a challenge where there is a lot of connectivity already, but it's spaghetti architecture, how you named it.
Yep.
And it needs to be simplified. There are a few projects ahead, like ERP integration and other steps that need to be taken. And that brought us back together to a request, and that request was setting up a UNS. And these past 50 slides, they showed how that process went, what were the steps, what were the evaluations of the UNS. So it gave a really cool insight. And I'm happy to show this case together with you. And once more, a shout out to Yuri, one of our engineers who had a major role in this project. Anything you want to close off with, Koenraad?
No, I can just.
Sorry, go ahead.
Yes, I would like to confirm that Yuri is an amazing engineer. He did an amazing job.
Cool. He will love this last 5 minutes of this case study.
Yeah.
Thanks, Koenraad, and we'll speak again soon.
Yes.
All
Okay.
right. Bye-bye.
Thanks. Bye.